Alright guys, let's solve the very first and most popular problem on LeetCode, that is toSum. We're given an array of integers nums and an integer target, and we have to return the indices of two numbers such that they add up to the target. Let's say in this one we are given an integer array of nums and an integer target, that is 9. And we have to return the indices of two numbers, that is 2 and 7, which add up to the target 9. And the indices of 2 and 7 are 0 and 1. Note that each input will have exactly one solution and you may not use the same element twice. That is, in this case, our target is 6 and we cannot do 3 and 3 equals 6. That is, we cannot return the same index twice. So what we are supposed to do is to just move forward and return 2 and 4, which equals 6. Similarly, in the next case, our target is 6, but we can return 3 and 3 indices because they are different numbers, and we can return the indices for these 2, 3, and 3s because they are different numbers, that is, they are on different indices. So the indices will be 0 and 1. And one more thing is we can return the answer in any order, that is, we can either return 0 and 1 or 1 and 0. And we will be solving it in big O of n time complexity with just one loop. So we have to find two numbers in this array that add up to the given target and return their indices. Now, the most straightforward way is to check every possible pair, like take one number and try adding it with every other number to see if it makes the target. Like this, 2 would be checked against every other number in the array. Similarly, the rest of the elements of the array would also be checked against each number. That approach would take big O of n square, which is too slow for large arrays. So let's think of something smarter. So instead of checking all pairs, we could somehow remember which numbers we have already seen and quickly check if the other number we need has appeared before. Okay, so let's start with the very first number, that is 2. What number do I need with 2 to make it 9? That is 9 minus 2, which is equals to 7. So have we seen 7 before? Not yet. So we'll store 2 in the map and we'll store its index, that is 0, as its value, which basically means that if someone ever needs a 2 later, it is at index 0. Okay, so move on to the next number, which is 7. So what number do I need with 7 to make it 9? That is 9 minus 7 equals 2. So have we seen 2 before in a map? Yes. At index 0. So we will simply return indices, that is 0 of the one in the map and 1 of our current number, which is 7 in this case. And that's exactly the idea. We use a hash map or dictionary to store each number and its index as we traverse to the array only once, and it utilizes big O of n time complexity. So to summarize the approach, we first initialize an empty hash map, then we iterate through the whole array, and for each number we compute its complement, that is difference. And if the complement is found in the map, we return the indices, and if not, we add the number to the map and continue. Now let's code it up. We first initialize an empty map, that is equals to mymap. Next, we use a for loop to iterate through the array. Then we compute the complement, that is difference equals target minus our current number, that is nums I. Next, we'll check if the complement is already present in the map, and if it's true, we will return our current index and the index of our complement in the map, that is, we'll pass complement as the key. In the else block, we'll handle the case when the complement is not already present in the map, and we'll insert it in the map, that is mymap. And for the key, we would store our current value, that is nums I, and for the value in the hash map, we would be storing our current index, which is I. Let's quickly dry run the code with our example array, that is 3, 2, 4, and target 6. So for the first line, we start with an empty map, and in the next line, our loop has a range of length of nums, which is 3, so we'll run a loop from 0 to 2. And for our first iteration, we'll check our complement, that is for I equals 0. We will check target, which is 6 minus nums at I, which is our current number, that is 3. So it will be equal to 3. Then we'll check if our difference, that is 3, is present in the map. So this will evaluate to false. So we'll move to the else block, and this will insert our current number, that is nums I, which is 3, as a key in the map, and its value will be I, which is our current index, that is 0 in this case. So our next iteration will be I equals 1. And for this, we'll move to line number 5, that is a compute our complement, which would be equal to target, that is 6 minus our current number, which is 2. So our current complement is 4. Then in the next line, we'll check if our complement is present in the map. No. Then we'll move to the else block and insert it. That is our current nums at I, which is 2, as a key in the map, and its value will be our current index, which is 1. So for the third iteration, our I is now equals 2, and we'll compute our complement, which is target 6 minus our current number, which is at index 2, we have 4. So 6 minus 4 gives us 2. Then we'll check if our difference or complement is present in the map. So 2 is present in the map, that is over here. So we would return our I, that is current index, which is 2, and my map difference, that is in the map, where our complement is the key, which means the index of 2, that is 1. So we'll return 2 and 1. And we can return it in any order, that is 2 and 1 or 1 and 2. Both will work. Let's just submit this. So the time complexity for our code is big of 1 as we're using a loop only once. And the space complexity would also be big of n because we're using a hash map in it. That's it for the two-sum problem. If you found this helpful, please like, share, and subscribe to my channel. And please let me know in the comments what problem should we cover next. Thanks for watching. See you in the next video.